Hi everyone, and welcome back to the Hive tutorial series. This is more of a development log crossed with the tutorial, and today we're going to be looking at the Blender GUI implementation for Hive. It's quite important that the GUI supports the workflow that Hive follows, but also makes a lot of sense to existing users of logic brick and nodal logic systems. My job that I'm currently working on Hive is over the summer will be to make it more user-friendly, to implement a copy of the logic bricks in Hive, not just the functionality but also in a logic brick friendly manner, so that we can create a conversion script, and also just to make the GUI more robust and to support development of Hive overall. The original author of Hive has had to step away from its development. He's still developing the back end to a lot of the more complex parts of Hive, thankfully, but the rest of the system, which is relatively well built at the moment, needs development by another developer, which I am currently taking control of. So today we're going to look at the current progress of the Hive GUI, and there are certain features which don't work and may have worked in previous versions of this GUI, but I'm simply developing them as I go along, and I'm mainly looking at getting the main I'm sort of working at different tasks at different times. So I've implemented a few logic brick nodes / Blender game engine nodes that are quite useful to use. I've also implemented some user interface friendly tasks. I've added support for copying and pasting and other things like that. So I'm sort of moving around really, and this project will be done when I polish everything up, rather than completing individual tasks one by one. So enough for the introduction. You'll see that we're in the compositor view, and I've added a game logic window down here. To make this easier for us to use now, let's go to the Game tab, set the render engine to Blender Game, and in the Game tab, enable Show Debug Properties, add a property to the default cube called Prop, set it to integer, and debug. And that way we can use that later on. So if I start the game engine, you'll see we have a property cube and it's set to 0. Okay, so now what we're going to do is create a new node graph, and you'll see that, in fact, I'll delete it for now because in fact, no, we won't. I'm just remembering things that don't work. It doesn't have any Hive options apart from this tab because we haven't clicked use Hive logic. So if I click that, you'll see we get a node group. We're inside of a node group, and that's just because of how Hive implements things. So very quickly, let's just escape out of that using this go to parent node tree operator. We could alternatively use a tab. In fact, I don't know if you can. Anyway, long story short, that's how you change into the normal Hive view. And if you click Hive options and use Hive logic first, that won't happen. So you'll see that if I press Shift and A, we have some options. Search isn't implemented at the moment. Hive maps is relevant for us at the moment, so don't worry about that. And these might look quite familiar. We have actuators, sensors, and then some other things that might not make any sense. So the actuators and sensors are very straightforward. You're aware of how they already work. Now, an interesting thing about these, if we add one, and you must have already seen them in other nodal logic systems. These diagonal pins indicate that the output of this variable, or this output, is a pull output. And the pull output means that in order for this to update its state and give you new values, it has to have another node or another worker request a value from the pin. So if let's say we add very quickly a trigger if and connect the two. In order for this to update its state, this is a keyboard sensor, so in order for it to detect a new key press, you have to update it by pulling the value from it, and it'll perform some checks. So let's look at actually how a worker is implemented. This is a worker, it's a node or a worker, and we'll use the word node and worker interchangeably. Essentially, there are different layers to the Hive system. There's about 6, and in order for you to use it most effectively, it's quite useful to be aware of the different ones. A worker is this node, and it's comprised of segments. Now, segments are smaller parts, like the input pins, the output pins, and how they connect to one another. Hive doesn't use the word inputs and outputs for its pins on a worker. It instead uses the names antennae or antenna and output. So just the input name is different. And this is a worker. Now, other words you might have heard around the Hive system is bee, drone, and also Dragonfly. So very quickly, the B module is essentially home to all of the Hive code. It's really most of the backbone of what goes on, apart from the GUI. So it's the implementation of Hive. And the segments are also belong to B, which is the library. So the segments are the smaller parts of the worker. There's also drones. Now drones might be a little bit of a misnomer. Drones essentially are a means of giving functionality to a Hive through a special plugin interface. And they're quite useful because you simply include them in the Hive and they give it more functionality. And the purpose of having drones is that essentially you can run almost the exact same nodal logic. In fact, you can run the same nodal logic graph on different game engines, different Python environments, as long as you have the correct drones for each environment. And this means that you can, let's say you only have 5 workers, or 5 features, for example, moving objects, updating their properties and deleting them, then rather than having to update all of your nodes, which are set to game engine nodes, instead of having to change those out for Panda 3D nodes or other kinds of nodes, you can simply update how those nodes perform their respective tasks. So in that respect, a lot of nodes or a lot of workers become a little bit like complex interfaces to special functions under the hood. Now, if that doesn't make any sense to you, then don't worry. It will make more sense in time, and also it's really not important if you're using the GUI, and that's only for when you're actually coding things in Hive. So we have a message worker, and that currently isn't implemented yet. I need to add that. So we're going to go to Sparta, which is a standard library, and it basically mimics all of the logic bricks. It still uses some of the similar functions exposed by the Hive system for Blender, but it does it in a more logic brick friendly fashion. So if you're used to using logic bricks, it will make sense. And we're going to add ourselves a sensor, and it's a keyboard sensor. And in the parameters here, you can see we have a key parameter which can change to space, and that's going to now trigger when I press the space key. You might wonder about if I want to release a key or if I want to hold a key, and that's actually implemented if we change the Hive level. So currently you'll see that the Hive level is 1 and Sparta. This is the Hive level here. And if I click it and set it to Advanced Sparta, you'll see we get more options. At the moment, you can't do this whilst you have a connection between 2 workers, so be careful. But this branch is in my GitHub, by the way. That is an advanced feature, so don't worry about it for now. If you're a new user, click Stick to Sparta. And then only move to Advanced Sparta when you're getting more comfortable. So we're gonna don't worry about any of the other options. The only thing we need to worry about is the parameters here. So we're going to let it occur on key press and on the space key. Now what we're going to do is add a Sparta trigger. Having already mentioned the purpose of diagonal pins, we have a circular pin, and this is red, and this indicates it's a trigger, push trigger. You don't have pull triggers in Hive, only push triggers. So in order to explain how that works, special segments themselves, individual segments, can be triggered, meaning they're basically told to update their state, and they can trigger other segments and so on. Trigger segments are essentially a connection between 2 different segments, or in this, you can imagine it being workers, to be honest. They're a connection between 2 different sockets or 2 different pins, and also other segments in the B library. And what it does is essentially it pushes from the output trigger to the input trigger, and asks the receiver to update its state. When this node is triggered, it can pull a value from the keyboard, which is why I've connected them here. This dashed line indicates it's a pull connection. So we'll come on to how that works in a minute. We can now move this up here. For now, don't rename or relabel nodes. Unfortunately, that might not be supported through the existing node UI, because it's a means of identifying nodes for the for the Blender UI implementation. We might actually change it so it then uses the Python ID or something, but for now, just don't change these, unfortunately. It will be supported by actually changing the worker ID here in the future. So this if trigger, to explain what it does, is updated every frame, and this receives events every frame. And essentially, when this receives events every frame, it will update the value of this variable well, the variable that is connected to this output pin. So let's say that you press a key on frame 6, then on frame 6 this active value will become true, but this doesn't change or affect this node here. This worker will only be affected by asking the keyboard sensor of the value of its active pin, and if that is true, then this worker will trigger by pushing an output through this trigger output. And the reason is certain nodes use a trigger input as a means of triggering them, so we need to be able to get that. So now let's add an actuator, and you're familiar with these, and we're going to add something called a mod property actuator, which is a modify property actuator. Now, this is where things get a little bit more complex. So I'm just going to quickly up the DPI so we can see what's going on. System, and then, where is it? Oh no, yes, DPI. And essentially you'll see that we have lots of parameters here. Now, to explain very quickly what everything does, this panel here is responsible for the ID and the profile, and this is all kind of more advanced stuff you don't need to worry about for now. The worker type is quite useful for using Python, it's informative, and the profile basically hides or shows you extra inputs that might be useful. Now the params place is the way you're going to be spending most of your time. This is the parameters of the individual worker, like this one for example, which doesn't have any params, or this mod property one which does. And we can change the modification mode, which is the way in which we modify the game object property, which is what this worker does. We have the value. We can change what we do to the property. So in this case, add would add a value of 0 to the existing game property, and we use the name property name input so we can tell it what name of property we want to change on the object. Now at the moment you'll see in the meta params, which is another interesting panel, we have some buttons and drop downs. To explain what each of these does, essentially meta params are used to create a special copy or a special implementation of a worker. So by itself, a worker with meta parameters can't be used. You have to create a special version of it. In this case, it defaults to a bound ID and a type of float. Now what this means is that this worker is assuming that it's working inside of a node tree or inside of a Hive map, which is bound to another object. And in more simple terms, that means it assumes that it's only belongs to this game object. And it is possible to do that in Hive. I currently haven't implemented it in my branch. So we need to tell it that in fact it's not working for just this game object, but in fact for all of them. So we set it to unbound ID mode, meaning that we're going to tell it the ID of the game object we're changing. And then the type is simply the variable type, and in this case it's an integer. Click create instance, and I've made a mistake. Oh, of course, you need to be careful you don't leave nodes connected at the moment. So things may have gone a little bit wrong. Let's quickly change that. Actuators, mod property. Okay, so to fix this, create a new file, use Hive logic, create a node tree, and we're going to do the following: add a trigger, add a keyboard sensor. We're going to change it to the space key. We're going to connect it to here. We're going to lift this up here. We're going to add an actuator mod property. We're going to change the ID mode to unbound and the variable type to int. Create an instance. Connect it to the if output, and we're going to now change some other settings. So now we've done that, let's expand the identifier parameter, and you'll see that if I click expand, it suddenly becomes possible to have a new node responsible for that value. Otherwise, if we fold it, we get to change it in the UI. And this is some special mechanics because of the way in which Hive works. These individual antennae and outputs don't have values. When you put something into the input, it doesn't change the input value of the worker. That is all done, that is all managed on how the worker implements it in code. So essentially the important thing to take away from this is that just because you see something on top on the Hive GUI layer doesn't mean it's that simple underneath. So this idea of folding and unfolding might seem a little bit alien, but it's quite useful. Essentially it allows you to change the value using a node rather than having to change it in the UI, which you can't change yourself in this node UI when the game is running, though you can change it from code. So we're going to unfold it for the purpose of this tutorial, and we're going to input the name of the object, which is cube, and then we go back to the mod property worker and change the property name to prop. Let's just increase my DPI once more so we can see what's going on. There we go, and I added a character there. And we're going to leave it as adding a value to that property, but we're going to change the modification value to 1, meaning that every time this is triggered, it will add a value of 1 to the property called prop on the cube. So let's add a prop, make it integer, and enable debug, as I meant to do earlier. So to quickly explain how this is all getting triggered so that you can kind of get a nice understanding of how it works, let's first press P, and I'm going to press space, and you'll see this property here is changing when I press space. Now to see how this works, how Hive is actually executing all of this code, it starts really, we can imagine it starts with the keyboard sensor, and every time you input a keyboard event, that keyboard sensor will receive that event and store it. And if that event matches the key it's looking for, it will set its output active variable value to true. Now this if worker is updated every frame, and it'll keep requesting the value of active from the keyboard, which causes the keyboard to then basically output that value from the variable it has. And if that value is true, it'll then send a trigger, push trigger, to this mod property worker. This mod property worker will then request the name of the game object from the mod property worker here, the variable worker. You'll see that this is of a type dragonfly.std.variable. So it'll get the identifier or the name of the cube when it's triggered. It'll then read the name of the property and essentially get the current value, add 1 to it, and save it. And that's how it works. And this is our basic nodal logic graph. Now if we press, we can save it. So I'm going to save it as test. And you can now see if I create a new blend file and then open up my recent ones, you'll see that they reload. Now the only slight confusion is that you can see we have this sort of weird, we're inside of a node group and there's some nodes behind it. Essentially, individual, we group logic into node groups, and that's just an implementation detail. So to escape that, just click the up arrow, and you'll see we're back to where we started. So I hope you enjoyed watching that. Thank you very much for following this tutorial series, and as this GUI updates and progresses, I will keep you updated.